want is equal to salary. So we are defining the field called salary and assigning it a variable for a particular object when we create it later on. Enter def get salary. By now you know what to do. Simply return self dot salary. Last, set technologies, open and close bracket, comma. This will receive a list of techs or technologies. I am calling it TECHS. Inside it, we'll do a self dot technologies is equal to the text that is being passed in. I'm assigning it to that. Last function, def get technologies, T capital. This will not require any parameter and it will simply return self dot technologies. Use the variable, no need to use the method name. That's it. So you have successfully defined a class with the accessor and mutator methods, inside which you are creating or defining and assigning the variable values for an instance. So create an object P1 is equal to programmer. We don't have a constructor here to pass in the arguments. So we are going to use P1 dot set. Start with name, John within double quotes. Save it. P1 dot set salary is equal to 10,000 bucks. And P1 dot set technologies. It needs a list of technologies. Pass in Java, comma, within double quotes, Java, comma, Hibernate, comma, Spring, comma. Now he's transitioning to Python. Python, which is the most popular programming language right now. And to access those details, we'll use the print P1 dot get name, print P1 dot get salary, and finally print P1 dot get technologies. Save it, run it, Python run, hit OK, and we see the details of John using accessor and mutator methods. You have defined setter methods and getter methods. The setter methods will always take parameters since we assign them to a object's variable, and then we use the getter methods to access their values. Class and instance variables inside the constructor or the init method. In this lecture, you will learn how to define instance functions or methods that can access these variables or fields. To do that, inside the class, define a function or a method called display. I want this method to simply display all these details that we are initializing, all these fields. Display, the method begins with open and square brackets, and it needs a self. Self, remember, always points to the object that is invoking that method. Whether it's a constructor or another function, self always points to the memory location of the object that is invoking that method or calling that method. So inside the method, print, you can grab these three statements from here or simply use print self dot name, print self dot price, and last but not the least, print self dot description. Now we need not use these prints here. Get rid of those prints and we can simply invoke this instance method using our object that we have created, p1 dot, and PyDev will show you all the available options. Select display. Display is the method we have created here. And if you look at this, you need not pass anything. This self is automatically passed by Python virtual machine at runtime. p2 dot display. Run the program and we still get the same output, but this time we are not printing the details. We are invoking the display function, which is an instance method or instance function on this class. And then we are invoking that method using the object dot display. So we use the dot to access the fields as well as the instance methods. In this lecture, you will define and use static fields or class level fields. You will do that by defining a class called student, and it will have a field called major, which is a static field. Go to Eclipse or PyDev, oops basics, right click, new file, call it student.py, student.py, define the class called student, colon, start by defining a static field called major is equal to, within double quotes, CSE, Computer Science Engineering is the branch. So we have defined a static or a class level field by globally defining it and assigning it a value. Let's define a constructor def underscore underscore init. It takes a self, comma, each student will have a roll number, comma, a name. So these here are instance variables, not static variables. Self dot roll number is equal to whatever roll number is being passed in here. I'm assigning it to self dot roll number. Similarly, self dot name is equal to name. So here we are defining instance variables or instance fields, but here this is static field, which is common for the entire class or for all the objects of that class. Create instances. S1 is equal to student, within brackets we need to pass in the roll number 1, comma, within double quotes say John. S2 is equal to student, roll number 2, comma, let's say Bill. Print S1 dot major. Let's see the major. Print S2 dot major. Print S1 dot name and print S2 dot name. Run this program and it is CSE, which is common, it is static. So you see, although you access it using S1 dot major, it is CSE, S2 dot major is also CSE, and then the names are different. Each object has its own name as we are assigning it here. You can also access a static field without using the object, using the class name student dot the variable name or the field name. Run the program, we still see the same output. So in this lecture, you have learned that to define a static field, you simply define it directly in the class, and to access it, unlike instance variables, you don't need an object. You can access it using the class name. In this lecture, you will define a static field as well as a static method. And in the process, you are going to count the number of objects of a particular class that are being created and display the count. Go to PyDev, new file, call it object counter.py, class object counter, colon, define a static field called number of objects. This field will store the number of objects. Every time an object is created, this will be incremented. Start with 0. Define a constructor def underscore underscore init is the method, brackets, takes a self. Within the constructor, we are not going to assign any fields. Simply access the static field that we have defined here using object counter, the class name, dot the field name, plus is equal to 1. I'm incrementing the value by 1 every time the init method is invoked. Now I want to display this value inside a static method. So define a static method called display count. This does not require a self because it is a static method. That's fine. At static method, you need to mark a static method with decorator called at static method. And you can get rid of this self because we are not going to use self inside it. Print object counter dot number of objects, simply displays the count. Now let's define some objects here. O1 is equal to object counter, that's the first object. O2 is equal to object counter. Invoke the static method. To invoke the static method, we can use the class name object counter dot display count. Run the program and the count is 2. So every time you create an object, the static field is being incremented, and then we are invoking the static method which displays the count for us. In this lecture, you will create your first inner class. That is, you will create a class called car which will have an inner class called engine. To do that, go to PyDev, create a new file, call it innerdemo.py. Innerdemo.py. Start by defining the outer class car colon. Define a constructor init, takes a self. A car will also have a make and a year, the brand and the year in which it was made. Self dot make is equal to the make that is being passed in as a parameter. Self dot year is equal to the year that is being passed in. So we have successfully created the outer class. Now to create an inner class, use the class keyword space the name of the class, which is engine colon. Define a constructor for it, def underscore underscore init, takes a self comma a unique number. Each engine will have a unique number. So self dot number is equal to number that is being passed in as a parameter. So you have successfully created an inner class as well. Now let's create objects of these classes. C is equal to car. And you need to pass in the make within double quotes, let's say BMW, comma, the year, let's say 2017. So you have created an instance of car. Now to create an instance of engine here, we'll have to use the outer class name C or the object dot engine. So you need an object of the outer class to create a object of the inner class, and define a method here, define def start, so that we'll see something in action. Def start, print within double quotes engine started. Assign this to E is equal to that E dot start. So we are creating an instance of the inner class using the object of the outer class, and then I am invoking the method called start on it. Run this program, Python run, hit OK, save it. And we need to pass in number. When we create an instance of engine, we need to pass in a number. So pass in 1, 2, 3, that is the error. It says there is a positional parameter, but we are not passing it in. Rerun the program and the output engine started. So in this lecture, you have successfully created an outer class, an inner class inside it called engine, which has one single field, and also a method called start. And you have created an instance of the inner class by first creating the instance of the outer class, and you have accessed the method on the inner class using that object. What is encapsulation? Encapsulation is about protecting the properties and the functionality of an object from other objects. The easiest way to remember that is by having a capsule diagram, just like a antibiotic medicine or capsule that we get from a pharmacy when we are sick. Here is a capsule that has all the properties and data of a particular object. Then we have all the methods that can access that data of that particular object. In most of the object-oriented languages, this capsule is called a class. The data, we call it properties and variables, and then functionality or the methods can access that data. So if other objects want to access this data, if we follow proper encapsulation, then they always have to go through these methods and functionality to access the data in that object. Another definition for encapsulation is writing the data and code into one single unit. In this lecture, we will learn how to mark a field as private and also about name mangling, using which we can access that private field through the object. So let's get started by creating a new PyDev project. Call it encapsulation. Eventually, we are going to implement encapsulation in this project. Python 3, 3.6 or same as the interpreter. Finish. Right click. Create a new file. Call it student.py. We are going to create a student class with two fields on it. Class, student. Define the constructor def underscore underscore init with the access to self dot id is equal to 123 and self dot student name is equal to John. So we are initializing two fields here. Now these two fields are not private yet. They are public. That is, we can directly access them by creating a object of this class. S is equal to student print s dot id will give us the id, print s dot name will give us the name. Run this, right click, do a run as Python run, and you will see both the fields there. No surprises so far. To make these two fields private, simply use underscore underscore, two underscores at the beginning of the fields. That will mark them as private. Once you do that, we will not be able to access them directly like this. Outside of that class, you cannot create an object, and using that object, you cannot access them because they are hidden. Go ahead, run it. Now you see an error. It says student object has no attribute called id. One way to access them is to create a method called display. Start with def. Def display is a method with access to self. We can use print self dot underscore underscore id, print self dot underscore underscore name. So if you try the same here with the object, you will still get an error. Underscore underscore id on the object, underscore underscore name. Save it, run it. You will still see a problem. Student object has no attribute underscore underscore id. You cannot access them here. So get rid of these two prints and invoke s dot display. Run the program. Now you see the output. So once you make a particular field as private, you can only access it through the methods of that object. Using the object, you cannot directly access it. But there is a syntax called name mangling, wherein print s dot underscore student underscore underscore id. I will tell you what this syntax is in a second. If you run it right now, you will see 1, 2, 3 again. So here the display method, if you comment it out, we can see the proper output, or get rid of that line. Run it. You see 1, 2, 3, which is coming from this syntax here. So in Python, when we make variables or fields private, they are not completely hidden. They are stored like this. Class name, right here student is the class name. So underscore class name underscore underscore id is the field name here. So you can access even a private field using object dot underscore the class name underscore underscore id. This is called name mangling. So in this lecture, you have learned how to make a field private, kind of, and then you have seen that you cannot directly access a field using the object name. Once you make it private, you will have to either go through the functions inside that class or methods inside that class, or use name mangling syntax. The name mangling syntax is object that we created dot underscore the class name and then the private field which you want to access, which is underscore underscore ID, or copy this, paste it, underscore underscore name. Save it, run it, and you can access the name as well. In the previous lecture, you have seen that the private fields on the student class are not really completely hidden from outside access. You are able to access them using the name mangling syntax. But you can still implement encapsulation here like how we do it in other programming languages using setters and getters. To do that, clean this up, get rid of this, get rid of these two as well. Inside the class, typically to implement encapsulation, define a setter and getter method for each field. Set ID is the first one. Self comma ID is passed to this. Inside it, self dot ID is equal to ID. So here we are dynamically assigning a field called ID to this class and also assigning it a value that is passed in. Here we get a warning in Eclipse saying that assignment to reserved built-in symbol ID. We can go to the settings and we can get rid of that warning by hitting Ctrl+1. If you see here, reserve assignment, if you add that, it will suppress that warning, or you can just ignore it. So that will suppress the warning for us. The next method is the def get ID that will return the ID back. Within this, you will do a return self dot ID. Similarly, you can define two methods for name, def space set name, comma, it takes a name as the input parameter, and it will set self dot name is equal to name. And the last method, def get name, which will return the name out, return self dot name. Save it. Now here, when we create an object, we invoke s dot set ID. That is the only way we can access the field ID. There is no other way. And s dot set name, pass in the name here. So ID, pass in some value 1, 2, 3, and the name itself is John. Print. To get the values, we use s dot get ID and print s dot get name. Save it, run it, and you see 1, 2, 3 and John, which we are getting through the accessor methods. So these methods here are called the mutator methods because we are changing the values. The setter methods, set ID and set name, are the mutator methods, and get ID and the get name are called accessor methods because we are accessing the values. That is how typically we implement encapsulation in many object-oriented programming languages. Inheritance is the process of defining a new object with the help of an existing object. Let's have a look at two important things in inheritance by looking at an example. Now that we have iPhone X in the market, Apple will be launching the next version of iPhone very soon. And this new version can access a lot of existing functionality from iPhone X. That is, it can inherit a lot of functionality and features from iPhone X. The way we take pictures, the way we make calls, how we access our email, etc. could still remain the same. And at the same time, the newer version of iPhone can upgrade or update the existing functionality. Like the camera could be better, it could be better performing, and more. So in inheritance, the two key principles are accessing the existing object's functionality and features, and if required, updating the existing object's functionality and features in the newer version or the newer object that we are creating. Two other terms that we usually hear when we talk about inheritance are reusability and is a relationship. For example, if we have BMW and Audi, which are two car brands, both these will have a lot of functionality in common. So we can push all that functionality into a parent class called car, and we can reuse that functionality across these classes. At the same time, if we have two bus brands, Volvo and Benz, both of these bus brands will have a lot of things in common which can be pushed into a common class called bus, which will be the parent class, and that functionality can be reused across these two classes. Now, car and bus can have a lot of things in common as well. All that functionality can be pushed into a parent class called vehicle, and that can be reused across car and bus. So inheritance gives us reusability of a lot of features and code. And the last term is a relation. It's just a term that is used when we talk about inheritance. Here, a car is a vehicle and a BMW is a car brand. Similarly, a Audi is a car, a bus is a vehicle, a Volvo is a bus, a Benz is a bus. So this relationship between each of these is referred to with the is a term. In this lecture, you will see inheritance in action by implementing the BMW use case. That is, you will define a class called BMW with make, model and year as fields on it. And then you will define two more classes which will inherit all these fields from BMW. They will also define their own fields called cruise control enabled and parking assist enabled respectively. So 3 series and 5 series are the child classes of BMW. Go to PyDev, new PyDev project, call it inheritance. Select the grammar version and the interpreter, finish. Create a new file called bmw.py. The first class we are creating is BMW. Define the init method __init, and there will be 3 fields on it. Self.make is equal to, we'll assign it by passing a parameter. So make, comma, model, comma, year are the 3 parameters. Assign make self.model is equal to the model that's passed in, and finally self.year is equal to the year that is passed in. Get rid of the semicolons, save it. Next, we'll define another class, class 3 series. And to inherit BMW, the 3 series should use brackets BMW. That is how we inherit in Python. There is no additional keywords like extends here. Simply the class name within brackets, the parent class name, and we will inherit from that class. Define the init method here as well, def __init. It takes self. In addition to that, the 3 series needs cruise control enabled. So cruise control enabled, and also it needs to pass in all the 3 fields for the parent class so that it can be initialized. When we create an instance or an object of the child class, we also want to initialize all these fields on the parent class so that the child class can use them. So make, model and year. The first line inside a child class's constructor is to invoke the parent class's constructor in any programming language. So BMW in Python, we do it using the class name, the parent class name dot the init method. Pass in self, that comes in here, make, model and year, and self dot cruise control enabled. This is where we are defining a new field which is available only on the child class, and this cruise control enabled should be assigned to that field. Save it. You can copy this class, go 2 lines, paste it, call it 5 series. The 5 series also extends BMW. Instead of cruise control enabled, it will have a new field called parking assist enabled. Parking assist enabled, copy that, paste it here and on the right hand side. Everything else remains the same. We are invoking the parent class constructor. We are passing in the make, model and year, and we have set